Okay, here's another example of using calculus to help us sketch the graph. We have a function here, x to the 1/3 minus x to the 4/3, and we can take the derivatives. F prime of x, we use the power rule, so this is going to be 1/3 x to the minus 2/3 minus 4/3 times x to the 1/3. So we can factor out the lowest power of x. If we factor out 1/3, there's a common factor of 1/3, and then the lowest power of x is x to the negative 2/3, and then divide. We'll get a 1 here, and then 4/3 divided by 1/3 is 4, and for the then subtract the exponent. Exponent 1/3 minus negative 2/3 is 1/3 plus 2/3, which is 1. So you have x to the negative 2/3, 1/3 x to the negative 2/3 times the quantity 1 minus 4x. So negative exponent we can put on the bottom, so we can write this as 1 minus 4x over 3 x to the positive 2/3. And for exponential expressions, the denominator is the root and the numerator is a regular exponent. So we can write this as 1 minus 4x over 3 cube root of x squared. Okay, so this is going to have two critical numbers. It's going to be when x is 0 or x is equal to 1/4. If x is equal to 1/4, the derivative is 0. If x is equal to 0, then the derivative is undefined. And then we can plot some, pick some values of x to determine the sign. So if x is less than 0, for example, if x is negative 1, the denominator is going to be positive, and the numerator will be positive. We put in x equal to negative 1 here, so this is going to be positive. If x is, let's say, between 0 and 1/4, for example, 1/8, the numerator is going to be positive. 1 minus 4/8 is 1 minus a half, which is positive. And the denominator will also be positive, because you have if x is positive and you square it, you're still going to, and take the cube root, it's still going to be positive. So this will be positive here. And if x is more than 1/4, for example, if x is 1, the numerator is going to be negative, and you have 1 minus 4, which is negative 3. The denominator is positive, so it'll be negative. So at 1/4, you have positive slope, and then slope 0, and then negative slope. So that's going to be a local max here. Okay, so let's take a look at the second derivative. So the second derivative is the derivative of the derivative. So we go back to this formula here. A negative 2/3 times 1/3 would be negative 2/9, and then subtract 1 from the exponent. So there'd be negative 1 2/3, which is negative 5/3. And then 1/3 times 4/3 is 4/9. Subtract 1 from the exponent, that'll give us negative 2/3. So the lowest power of x is that's going to be the x to the negative 5/3, and we can also have a common factor of negative 2/9. So if we factor that out, that's negative 2/9 x to the negative 5/3, and then we'll have 1 minus 4/9 divided by 2/9 is 2. And for the exponential, you subtract the exponent. So negative 2/3 minus the negative 5/3 is going to be negative 2/3 plus 5/3, which is 3/3, which is 1. So you'll just have 1 minus 2x. Okay, so we can write this as a fraction, then minus 2 times the quantity 1 minus 2x over 9 cube root of x to the 5th power. Or if we distribute the minus sign, we'll have 2 parentheses 2x minus 1 over 9 cube root x to the 5th power. Okay, so it could possibly change concavity when x is equal to half, or when x is equal to 0. So at 1/2, second derivative is 0. At 0, the second derivative, both derivatives are undefined. And if x is less than 0, for example, if x is negative 1, we're going to have a negative numerator and a negative denominator, because we have 2 times negative 1 is negative, minus 1 is negative. And then the denominator is going to be, you have a negative number to an odd power is going to be negative. So negative divided by negative is positive. If x is between 0 and 1/2, for example, if x is 1/4, 2/4 minus 1 is going to be negative. The denominator will be positive. So this is going to be negative here. If x is more than 1/2, for example, if x is 1, everything is positive. So we have so we'll have the concavity is going to be concave up here, concave down, and concave up. Half is going to be an inflection point because it changes concavity. 0, yeah, 0 is also an inflection point because it's in the domain of the original function. Okay, so it's also useful to find the intercept. So the y-intercept is f of 0. So again, our function is f of x equal x to the 1/3 minus x to the 4/3. We can write that as cube root of x minus cube root of x to the 4th power. The y-intercept f of 0 is going to be just cube root of 0 minus cube root of 0 to the 4th power, which is 0. And the x-intercepts, you're going to solve f of x equals 0. That means that x to the 1/3 minus x to the 4/3 equals 0. You can factor out the lowest power of x, so it's x to the 1/3 times the quantity 1 minus x equals 0. So either x to the 1/3 equals 0, or 1 minus x equals 0. And if you cube both sides here, you get x equals 0, or if you add 1 x to both sides, you get x equals 1. So you have 2 x-intercepts, 0 and 1, 1 y-intercept at 0. Okay, so then we can plot the points and sketch the graph.